Welcome to pantechelearning. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. In this video, we are going to see what is dataset, how to train image datasets in MATLAB. Dataset, it is a huge collection of files which can be classified into multiple classes. For example, it may be a disease oriented or it may be a regular objects like pen, television, mobile phone, etc. The disease like the tumor, or it may be the tumor of a particular brain or tumor of the lung and pneumonia. So look, like this kind of different classes we will be having, and there will be a group of structure which is available for that. For each and every application, there are several data sets. For example, if you are just going for a particular face recognition, so inside that face recognition, if you are going, want to recognize a particular person's face means, then that person's image dataset should be available. So that is a major and important thing for a face recognition. Like that, for each and every object, the huge amount of images are required. So through image processing, we'll be able to process the number of images at the same time. Now, inside this particular image processing, the advanced level is nothing but to get into a machine learning or deep learning algorithms. So before getting into that, we have to process a multiple classes and a huge amount of data set before training to the algorithm. So for that only, for the past some of the videos we have seen something regarding towards the image processing and its multiple techniques. Now inside this training of datasets, we have to know what are the different types of datasets are available other than image. So like numerical dataset, bivariate dataset, multivariate dataset, categorical dataset, correlation datasets. Generally, if you say for the datasets means, it can be said as the image or the CSV files. So among from these two different types of dataset, these all things can be applicable. Like if we provide an image with the help of an image processing, those datasets can be converted into the numerical dataset in the form of a matrix. Then bivariate means dual variation can be applied. More than dual variations are called as multivariation. Categorical, each and every category of datasets can be arranged and we will be able to train towards the neural network algorithms. Correlation, which and all the datasets are related to their particular matching performances. So these kind of different datasets only it is available, which helps us to make the machine to learn in much more advanced techniques. Here, if a machine want to learn something, then definitely it must be trained. So who is going to train means ourselves only, it has to be trained. Like how a teacher guides the student for the particular subject. If we take a maths, how to add two numbers, how to subtract two numbers, how to subtract two-digit numbers. So like this kind of many things the teacher will be teaching to their students. Likewise, we have to train the machine like this image belongs to the robot, this image belongs to the vehicle, this image belongs to the ball. So like that each and every categories we have to teach to the machine, and each and every categories must be a huge amount of data. Huge amount means at least 2K to 5K images must be there, which provides a good accuracy and less loss of rate. So training of dataset, it is an initial step used in machine learning as well as the deep learning models to make machine a well learned kind of device, and at the same time those kind of devices only it is called as artificial intelligence. The requirements of a machine to train the dataset. So generally we will be thinking to training it is very simple, we can just process it and from that we will be able to extract the values, everything. So those things and all, it is a basic kind of training requirements which can be seen for the pattern recognition inside the SIFT, SURF or a KNN algorithm. So those kind of image purposes we can say. If we want to train a huge amount of data set means, definitely that system must contain a high-end processor integrated with a graphical processing unit. For example, in the system, we will be having a Ryzen 5 as well as the GPU of 1650 NVIDIA, which contains the CUDA driver, which can be enabled with the help of the CUDA driver for the training assistance. And in the next video, we will be seeing what happens if we start to train the huge amount of data inside an Intel processor without NVIDIA GPU and the Ryzen processor with the GPU, and only with GPU how the dataset should be trained. Now we are going to see how to train multiple class images inside the MATLAB for deep learning purpose. So here I have the two datasets. Now I am entering the data path into the MATLAB. So first, whenever we go for the MATLAB, the first step whatever we have to do means we have to copy the data path and give the access to the respective folders. So I'm going to paste about the data. So the address is most important, and the files whatever I have, it is two. One is cyst and another one is tumor. Those are the kidney images, CT scan. So totally I have 5240 images. Now I am opening transfer learning, which is already available inside the apps of MATLAB. For this function, it is best to start from 2021 version MATLAB. And in this video, we will be seeing how to train in normal CPU with GPU as well as GPU. So these three methods we will be seeing. Therefore, now the app has been turned on. First, we have to select whatever the architecture it is required to train. I have selected as ResNet 50. Now I should import the dataset from the respective folders and make sure that train deep learning whatever we have been provided, it must be in classification mode. So here we have to select the one option. Based on the subfolder only the data will be collected. Now everything has been imported. So therefore these are the particular images. If we just scroll down on the list, we will be able to see what and all the different lists are there. Now I am going to train this particular data set in a normal CPU. Okay, in this I have graphics card, but the graphic card is Intel graphics card, which doesn't support for the training. Once when we train inside this Intel graphics card, what will be the error displayed on it? So we have to change the augmentation, like the reflection should be enabled for R as well as Y, random reflection for x-axis and y-axis. And after changing it, we have to click on update. If you forget to click on update means the portion won't be changed. Then click on training options. So make sure first we are going to do with CPU. So the solver name may be the Adam or SGDM, any kinds of regressions. So here I have chosen SGDM. Now everything selected, click on train. Now a dialog box will be appearing, like providing the message as it takes a lot of time to train. So whether we are ready or not, click on train. Now the live progress table has been opened. So at present it is collecting the input data. So here I have just made as a time lapse. Generally it takes a lot of time to start and to train this much amount of images. Except GPU, if you use any other methods, it will take a lot of time. So here you can see what will be the accuracy at the initial and in between, how much amount of losses has been occurred, and we can also see that timing. So that elapsed time is almost real times only. Out of 5240, 27 has completed within 84 minutes 40 seconds. And 94 minutes, like that it keeps on going. When it reaches at the saturation point, it stops, and that will be the total training time. Let us wait till the saturation point gets reached out of 5240. So it has reached till 169 minutes, 177 minutes for 55. So at 184 minutes, we have received an error. Failed to load graphics driver, and which library means nvcuda.dll. This error means to train this kind of dataset, we require NVIDIA as well as CUDA driver. So NVIDIA's graphics processor along with CUDA driver is most important to train this kind of dataset. At next, let us see how to train the data in NVIDIA CUDA CPU, not the GPU one. We shall try with CPU. So the same steps to be followed to import the dataset. The same ResNet 50 and STDM has been selected. The only difference is here we are using the CPU with NVIDIA processor. So this almost takes around of 6 hours. So here we can see 81 for 136 minutes and still it is going on. But the accuracy and the losses are in the good percentage. But previously it took a lot of time once when we are working with the laptop Intel's CPU. And this whatever I have trained, it is Ryzen 5 and having NVIDIA 4GB graphics card along with this. So within 180 minutes the training has been completed. Now we are continuing the next process with NVIDIA GPU training, which is the fastest one while compared to the previous two trainings. So same methods we are following to upload the data, and here you can see NVIDIA GeForce 1650 is being installed into the system. So that GPU only now we are going to use for training the dataset. Import the required process. Now select the augmentations and the required parts. So these are the list of dataset. Now let us enable the augmentations for reflection purpose. Then training options. In GPU. So GPU has been selected. Now select the ResNet. Click on train. So click on train again. And now the process will be started. So it is about to start the training process now. So it has started. So this resource is nothing but known as single GPU graphical processing unit. Now the training is complete. So within 10 minutes it has been trained the entire images, 5240 images. So that is the advantage of GPU training, and that's why many of them are preferring to train by using GPU. Now once after completing, if you click on export, these trained sets can be exported into multiple types. Okay, either to the workspace of the MATLAB script, we can create a mat file, open neural network for Python with CUDA, with MATLAB we will be able to generate the code, and again we will be able to generate the GPU codes. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.